It's an asteroid bash and an asteroid smash. This week on Planetary Radio. I'm Sarah Ahmed of the Planetary Society, with more of the human adventure across our solar system and beyond. Every year on June 30th, the space community marks Asteroid Day, the United Nations-sanctioned day of public awareness about the risk of asteroid impacts. Markus Payer, Asteroid Foundation Chair, is going to join us to talk about this year's Asteroid Day festivities. And where are we in our journey to protect our planet from asteroid impacts? We'll get an update on the results of the first kinetic impactor test with Terik Daly, a member of the Double Asteroid Redirection Test, or DART mission team. And of course, we can't bring our dear Bruce Betts, Chief Scientist of the Planetary Society, back on for What's Up without getting an update on our Shoemaker Near-Earth Object Grant Program winners. Their efforts to save the world from dangerous asteroid impacts continue. And happy solstice to everyone around the world. June 20th was the longest or shortest day of the year, depending on what hemisphere you live in. I hope you're all having a wonderful beginning of winter in the south and a beautiful beginning of summer in the northern hemisphere. If you love Planetary Radio and want to stay informed about the latest space discoveries, make sure you hit that subscribe button on your favorite podcasting platform. By subscribing, you'll never miss an episode filled with new and awe-inspiring ways to know the cosmos and our place within it. So, why do we celebrate Asteroid Day? Here's a message from Ardi Halomeini, Director of the United Nations Office of Outer Space Affairs.
Good morning, good afternoon, and good evening to all. Established in December 2016 by the United Nations General Assembly, the 30th of June was declared as International Asteroid Day in order to observe each year at the international level the anniversary of the Tunguska impact over Siberia on 30th of June 1908, and to raise public awareness about the asteroid impact hazard. International Asteroid Day is therefore a global awareness campaign that provides an opportunity to learn about the risks and the opportunities presented by asteroids. As we in the United Nations Office for Outer Space Affairs work with member states, space agencies, and their planetary defense experts to strengthen international coordination and preparedness in case of an asteroid impact hazard, we hear experts say we need to find asteroids before they find us. In 2029, on Friday the 13th of April to be exact, the asteroid 99942 Apophis will pass safely between the distance of the geostationary orbit and Earth, which in astronomical terms is an extremely close approach. On this single day, we will have a once-in-a-lifetime opportunity to see an asteroid with the naked eye under a dark sky. We're working with our partners, including the Asteroid Foundation, to take advantage of this unique occasion and to dedicate the year 2029 to an international year of asteroid awareness and planetary defense. We count on your engagement. I wish you all a happy International Asteroid Day. Thank you.
I don't know about you, but I'm already thinking of taking a trip to Europe or maybe Northern Africa to try to spot asteroid Apophis in 2029. It won't be visible from everywhere on Earth when it flies by, so you'll have to plan accordingly. It might be a little scary seeing an asteroid get that close to Earth, but it's going to be an excellent chance to study it more. The OSIRIS-REx spacecraft, which returned a sample from asteroid Bennu to Earth last year, is already gearing up for a rendezvous with Apophis after its close approach. You can learn more about that on our Planetary Radio episode called OSIRIS-REx Goes Apex. I'll link to that on the website for this episode of Planetary Radio. Ardi Halomeini also mentioned the Tunguska event in 1908. We'll hear more about that in a moment with our next guest, Markus Payer. He's a board director and chair of the Asteroid Foundation. Asteroid Day's website and activities have all been part of the official programming of the Asteroid Foundation since it was established in 2017. Their mission is to promote awareness of the opportunities and challenges presented by asteroids and the emerging space economy. Hi, Markus.
Hi, Sarah. Good to speak to you.
It's Asteroid Day once again, and I know it's always really busy in the lead up to these in-person events, so thanks for taking some time to speak with us.
Pleasure.
So Asteroid Day has a really interesting foundation story, and as with a lot of good space stories in the last few decades, Queen's Brian May is involved. How did Asteroid Day get started?
It got started in California, actually, and you mentioned one of the founding members. There was a filmmaker, there was Brian May, there was Danica Remy, and they set up Asteroid Foundation and obtained it as an annual day in the United Nations calendar. And then with some Luxembourg delegations, we went very often to the US and also to California and, meet space people, because Luxembourg is a growing space business and has invested and engaged a lot. And we met the Asteroid Day people in the US. And actually, at the time, the delegation and the Minister of Economy, who was also responsible for space, suggested that Asteroid Day comes to Luxembourg and gets an inception under, Luxembourgish foundation structure. And that's what happened. So the Asteroid Foundation was incepted in Luxembourg 9 years ago and started its activities from the little Grand Duchy.
And this day also marks a very important anniversary for planetary defense, which is the Tunguska air blast. Can you tell us a little bit about what happened there and why this is the anniversary that we mark every year with Asteroid Day?
Asteroid Day started, as you say, as an initiative to, attract people's awareness and make people aware of the role of asteroids and the risk of asteroids. So it was very much the planetary defense topic that was characterizing the programs that Asteroid Day was running. When we came to California and met the people from Asteroid Day, we had something else in mind on top, which is complementary, which was that Luxembourg started at the time, a couple of years ago, to think about space resources. And at the time it was called space mining. So Luxembourg, you may know, historically is a mining country, steel industry and all this. So we had some experience in mining, and we had a lot of experience in space already. And we looked at asteroids not only as a risk, as objects that can fall on our head, as they did before in the past, with partly catastrophic effects and impacts, but also as a resource, as a chance. So glass half empty and glass half full, And we combined this story and integrated into our Asteroid Day storytelling. And that was then about, yes, we want to talk about asteroid missions. We want to talk about why these missions make sense, because they help us to develop planetary defense. But they also help us to develop our use of space resources, meaning missions that go to asteroids, not only to study how eventually we could deflect them when they come too close to our planet, but also how we could go there and actually use the resources. Who is able to do that technically? Who is allowed to do that? You need kind of space law to regulate that. And all the things Luxembourg was putting together, these elements, at the time was the only country besides the US, a very big country and a very small country, who both had a space law that would allow people, or that would clarify the question, what happens if you are mining an asteroid? To whom does it belong? And so that's how it started, kind of completing the story and complementing it also with the opportunity side that asteroids offer us.
Well, I know it seems like a very science fiction idea. We've seen this kind of thing, say, in The Expanse with the belters that are out there mining the asteroid belt. But having laws in place such that we can do this ethically is really important, especially now that we've found asteroids like Psyche, which we think are mostly metallic. There are so many resources out there that could improve life on Earth, but we want to make sure that we do that in a very thoughtful way. So I'm glad that people are taking those steps early.
Yeah, it sounds like science fiction. But the word science fiction has also the element science in it. It's not only fiction. So Luxembourg has made great efforts also through university, through its space cluster and space business, to end the legal side we mentioned, and it's about policies here, to actually bring this closer from fiction to science. And as I said, university, for example, in Luxembourg has a lot of knowledge that if you study their presentations and their education and all the things that they develop, that actually you realize we are on our way. And we are also on our way when you look at the missions, public entities are spending, and it's NASA, it's ESA, it's the space agencies in the US and in Europe and also others that invest enormous money, and basically it's taxpayer money, right? It's public money in missions. And 2024, as you might know, is an important year for asteroid missions because Hera is coming up. And so we are working very closely and are pleased to work even more closely with ESA, the European Space Agency, on our Asteroid Day program 2024, because 2024 is the Hera year. 2024 is an asteroid year.
In a moment, we're going to be getting an update on the DART mission with Terik Daly, and we'll speak a little bit about the Hera mission, because I cannot wait to see what those images are like in the aftermath of that DART impact. I can't even imagine what we're going to be learning about this type of asteroid, but also our ability to deflect them in case of emergency. This is going to be a really cool follow-on mission.
Yeah, and it's an important example also of how closely NASA and ESA can work together, can send two missions that are totally complementary. One that has actually, that had the impact, and it was very successful, or even amazingly successful, this mission. And now the other one that, as a scientist and engineer, called it going back to the place of crime, quote unquote. And looking at the impact that actually it had. And this will help us to really develop and fine-tune our systems, how we go to asteroids and how we can impact them and how we can also benefit from them.
Well, to mark Asteroid Day this year, you're throwing a giant event in Luxembourg on June 28th and 29th. What's going to be happening at that event?
Yeah, first of all, the date might seem odd because Asteroid Day is the 30th of June in the United Nations calendar, but it happens that the 30th of June is a Sunday, so it's not ideal for the kind of program that we are running. We are building it basically on 3 pillars, and these pillars are very much about creating awareness, educating people on space, on asteroids, on science, on missions and everything. So it's a more, really scientific and expert part. And then there is another part which is more about celebrating space, inviting kids and youngsters and students and families and all together to an event where they actually can touch it, feel it, what's it like to watch space, what's it like to be an astronomist and all these things. So basically this means the 3 pillars are, we have a space lecture, an Asteroid Day lecture, we call it, where actually this expert part and science part is at the forefront and the focus. And then there's the Asteroid Day Festival, where we invite people here, that's the next day, the 29th, the entire public, whoever is interested, to come to us, join us in the museum and play with it, feel it, meet astronauts. Astronauts are always at Asteroid Day, and we always invite them, and they are, kind of the main ambassadors for every kind of space mission, space exploration, and therefore also for us. They are helping us a lot. And another element that is tackling, the aspect of education, we have a great space cluster in our countries. In the US, also Luxembourg has a significant space cluster. And this is about business. And these people need talent. These people need to explain to young people why it would make sense to not only go to work in banking or in luxury good companies, but why space would make sense. And that's a kind of education that we want to also develop. And that's why we also, as a third part of our program, go into schools in Luxembourg with astronauts and have them talk about what is it, space? What's it like to be in space? What's it like to go there, to come back? And this is kind of embedding the asteroid story in a larger context about interesting people in space. And you can't imagine when we have, dozens and dozens or hundreds even of pupils in front of us in different schools, how clever they are, how fascinated they are, and how interesting space is actually. And also good to see that there is already a significant, important level of knowledge amongst people who are only 12, 13, 14 years old about what is space and what's going on with our space missions.
I used to teach field trips at an observatory where we would take on hundreds of kids a day. And honestly, it was really surprising to me starting out just how knowledgeable they were, how passionate about it. But some of these children are already thinking about making asteroids a part of their future. One child, he was 10 years old, actually came up to me and is like, when I grow up, I'm going to be an asteroid miner. I was like, I love that you're thinking about this so early because we're going to need people like you. It's going to be increasingly more important to have people passionate about this as they grow up.
Yeah, we had a program last year that was actually presented at our Asteroid Day last year, where Luxembourg invited young people to become astronaut for a day, which meant gaining a seat on a flight with zero gravity. They left in the morning and they came back in the afternoon and landed at Luxembourg Airport, and where the Minister of Economy was even on the flight. He tried it out too. And they have, they have become really passionate about space. They have become our youngest ambassadors now. And they have already given the message to many others, young people, what fascinating things space can be for youngsters. And a couple of them will definitely work in space, I hope, in one day.
I'm sure it's changing the lives of so many kids in Luxembourg. And I know that not everybody can be there to participate in this event. So thankfully, you're live streaming all these Asteroid Day events online for people. I believe that the live stream starts at around 1 a.m. my time. But, honestly, if I'd wanted to get any sleep at night, I don't think I would have gone into astronomy.
Yeah, astronomy takes place at night very often, The science panel's scientific part is streamed, actually, yes, as you say. And this is very important for us because Asteroid Day is not only a physical event and now has become a 2-day event in Luxembourg. It also is an event on a global platform. We have seen over years communities mushrooming on every continent using our material, using our kits that we provide, and setting up, Asteroid Day events, whether it's in Brazil or in India, everywhere. And this is not centralized. This is just an open source for us, where people can join the platform. And this has actually generated enormous momentum. And same we will do this year. This will then not only take place in Luxembourg, but it will take place in many different cities and places over the world.
There's actually a map on the Asteroid Day website, and I'll link to that on this episode page for Planetary Radio at planetary.org/radio so you can watch. We're also going to share the link for the live stream in our member community. So anybody who's a Planetary Society member will be easily able to find that live stream. It's always so much fun each year. And we're at a kind of key moment in the history of asteroid research, but also planetary defense, and that we've not only returned samples with Japanese and United States missions from asteroids to Earth, but we also just saw the successful impact of DART into asteroid Dimorphos. And this is our first kinetic impactor test in the history of humanity. We've never gone and slammed into an asteroid before to see how we could change it. So what does this moment mean for the history of asteroid research and planetary defense? And how do you think people are going to look back on this moment in history and reflect on what we've done?
These are very important steps where a vision is materializing, and literally materializing when we hold material from asteroids in our hands. And it means that these objects about which we still do not know enough. These objects they exist. They can come close to Earth from time to time, but they can also be very beneficial for humankind. I think these moments when we have missions, when we have scientists really developing models and developing knowledge, deep knowledge about deep space and about asteroids, are a proof point that this is a vision that can translate into missions and that can materialize. It will take time. It's not for tomorrow. There is no way of thinking that an asteroid economy would exist in a couple of years. Sometimes you need visions and long-haul activities and plans in order to get there. We had this experience when we were dreaming about space in science fiction, and when actually this fiction changed into science. And people like Arthur Clarke were exactly in the middle of it. A scientist who was a science fiction author, but at the same time a scientist, who turned fiction into science. And he was the one who imagined that geostationary orbit would exist. And he found it, and we found it. We use it today. So same will go for this belt of objects that is further out in space. We need time, but we are investing in it. We are engaging. We are passionate about it. And every single step that a scientist takes, that a study takes, and that a mission takes is a milestone on the way to realize that mission. And hopefully, it is also something that actually qualifies really as a planetary activity and as a peaceful activity, as an activity that helps our economies and our societies to develop and evolve.
Planetary defense is something that impacts all of us. And this is a thing that we all need to worry about because we all live together on one planet and it impacts all of our countries, every human and every creature on Earth. This is our moment to make the dreams that could potentially save our world and all the creatures on it. So thank you for spending so much time teaching people about this and sharing the passion for space because we need this. And I hope you have a really beautiful asteroid day, you and the entire team.
I must say also thank you to you for your consistent support since a long time. You're very close to us and have done enormous things to help Asteroid Day take off and evolve. Thank you very much. And the community you're reaching and we are talking to here has been extremely helpful and passionate about, helping Asteroid Foundation and Asteroid Day to fly.
All of us together, one giant space family trying to learn about our place in the universe. Thank you so much, Markus.
Thank you.
Our collective understanding of asteroids and our shared ability to defend our planet from potential impacts has advanced so much in recent decades. As a global community, we still need to do a lot to detect near-Earth objects and to develop strategies for mitigating these potential threats, but we're off to a great start. There are several active asteroid missions in our solar system. NASA's Psyche mission is on its way to investigate a metal-rich asteroid. People are really excited about that one because it might mean a lot for future asteroid mining endeavors. The Lucy mission, which will explore Jupiter's Trojan asteroids, has already had a successful test flyby of the asteroid Dinkinesh, and it got close enough to get images of its small double-lobed moon. OSIRIS-APEX, which we mentioned earlier, is all set to rendezvous with asteroid Apophis after its close brush by Earth in 2029. Then there's the NEOWISE Space Telescope, which is working to help us detect and track near-Earth objects. And of course, the Japan Aerospace Exploration Agency's Hayabusa 2 mission, which has already returned samples from asteroid Ryugu and is on its way to its next target. Everyone at the Planetary Society is also really looking forward to NASA's NEO-Surveyor Space Telescope. It's going to find 90% of all near-Earth objects that are big enough to level a city. Our members and supporters have advocated for that mission for years, and we're really glad that it's moving forward. Thanks to all of the space advocates that helped make that happen. In the next few years, the China National Space Administration's Tianwen-2 mission plans to snag another sample from an asteroid to return to Earth. And their space agency is working toward another asteroid deflection test. The first asteroid deflection test happened just a couple of years ago. NASA's Double Asteroid Redirection Test, or DART mission, launched in November 2021, and it marked a turning point in planetary defense. DART aimed to test the kinetic impactor technique by targeting a near-Earth asteroid called Dimorphos and its moon Dimorphos. Kinetic impactors are pretty straightforward. Just slam one or more spacecraft into an asteroid at high speed to change its orbit and move it away from Earth. This approach shows a lot of promise, particularly with asteroids that we've detected far enough in advance. Asteroid Didymos and its moon Dimorphos were an ideal test. Their orbital relationship allowed us to precisely measure the changes post-impact. On September 26, 2022, after almost a year-long journey through space, DART successfully collided with Dimorphos and changed its orbit. Joining us next is Dr. Terik Daly, a planetary scientist and the Planetary Impact Laboratory Manager at Johns Hopkins Applied Physics Lab in Maryland, USA. He also serves as the deputy instrument scientist for Draco, the camera that was aboard DART before it smashed into the asteroid. Terik's research focuses on the formation and evolution of the solar system, using a combination of lab experiments, computer modeling, and spacecraft data analysis, focusing on fundamental processes like impact cratering. He'll tell us more about the results of the DART impact, and we'll look forward to the European Space Agency's follow-up mission called Hera, which is going to launch later this year. Hi, Terik.
Hi, I'm so happy to be here. Thank you.
I'm so happy to have you because I feel like every space mission impacts you differently emotionally, but I have this connection to DART because it was my first space launch.
That's so cool. It was mine too. And,
really?
Yes. No, I was part of the NASA broadcast that happened. So I was in Mission Operations Center and thereabouts the night of launch. So I did not actually see the rocket, but I was part of that, broadcast for the launch. But it was so really cool to see the images of that rocket going up, but also to be right there when communication was established with the spacecraft and to have that confirmation with mission operations that, yes, we are doing well, we are talking to that spacecraft, and to kind of have that information, in advance of the rest of the world, that was a highlight.
So we haven't had an update on DART since we actually launched this mission. And unfortunately, the spacecraft itself was destroyed in order to actually accomplish this. But we did get some follow-up observations from the Italian Space Agency's Licia Cube and people all over the world. Telescopes, space agencies, asteroid hunters all turned their instruments to take a look at this. What was it like being at the center of such a global science effort?
Yeah, well, so I think I would first challenge a little bit the phrasing that unfortunately this spacecraft got destroyed, because that was really the intent of the mission, was to take this spacecraft and slam it into an asteroid. So from my perspective, it is fortunate the spacecraft was destroyed, because what that tells us is that we actually have the technology to potentially prevent an asteroid impact should the need arise. So one of the highlights for me is that this was a line in the sand moment. If you look prior to September 26, 2022, back in time from that point, there were theories and there were ideas about how you might potentially prevent an asteroid from slamming into the Earth and causing devastation. But they were just that, right? They were theories, they were ideas that kind of, the physics worked, but you didn't know for real, like how the asteroid would respond and if we really had the technology. Once DART slammed itself into that asteroid, because it was a self-flying spacecraft in the last 4 hours, we then knew, yes, humanity has what it takes to potentially prevent an asteroid impact. And for me, my role the night of impact was to be the interface between the Mission Operations Center and the media team. So in one ear, I had mission operations, and then the other half of my ears, the other ear is focusing on what all the press people are needing and what the broadcast is doing, and making sure that all the images from the spacecraft were streaming out. And it was quite spectacular as we saw Dimorphos fill the field of view, and partly because we had done so many rehearsals to make sure that the spacecraft performed well, and we actually did hit that asteroid. We had been in so many rehearsals. It was like watching paint dry for like 4 hours, seeing this point of light moving. And it was really just in the last couple of minutes that you could tell it wasn't a test, because you saw this new world coming to light that had never been seen before. So the first highlight was we slammed into that asteroid. And then shortly afterwards, telescopes, as you mentioned, verified that we had in fact changed that asteroid's path through space. That came from a couple of sources. One was telescopes on the ground that used optical images. The other was radar. So those optical telescopes were looking for dips in the brightness of the asteroid system as a function of time, and the spacing of those brightness told you how long it took Dimorphos to go around the asteroid. Radar was another approach. And we found that by more than half an hour, actually, DART decreased the orbital period of Dimorphos around Didymos. And that was the confirmation that, yes, we actually moved the path of this celestial object. And then over the course of the next days and weeks, we saw really cool things like this tail, this ejecta that was thrown off the spacecraft got reshaped into this long tail that, like, if you were to try to wrap it around the Earth, would wrap more than halfway around the Earth. And then we saw the spectacular images from Licia Cube coming back, specifically from their Luke camera, which had color, where you saw these streamers of ejecta coming off of Dimorphos and these boulders. You could track individual boulders and their paths in these images. And there was, to your point about the international component, there were telescopes observing on all 7 continents, as well as 3 in space. We had James Webb, we had Hubble, and we had NASA's Lucy mission. And this was the first time that JWST and Hubble looked at the same thing at about the same time. So this just wonderful international collaboration for this international problem of planetary defense, because an asteroid could care less where you live. It just knows that Earth is where Earth is.
And that's why this is so important. This is the beginning, it feels like, of a whole new age of us being able to protect ourselves in ways that we weren't able to before. Of course, there's a long way to go, but what an impactful start to this age of planetary defense. But it actually ended up kind of changing the orbit of this thing a little more than I had personally expected. How did this compare to the projections of how much we were going to change Dimorphos' orbit?
We actually had a really broad range of predictions and what the outcome of the DART impact could be. One of the key uncertainties was how the asteroid would respond. So we know the spacecraft's mass, we know its velocity, therefore we know how much momentum the spacecraft imparted to the asteroid. The question was, or a question was, what would the asteroid do in response? Would it act more like, say, a hunk of concrete, or like a pile of sand, or something in between? And depending on how that asteroid behaved, it could really change that shift in the orbital period. So if it were really strong, think concrete, then you wouldn't have a lot of stuff thrown off the asteroid after the impact. And so you wouldn't really get an extra shove from that ejected material, and you'd have a smaller change in the orbital period. If it's really weak, you'd get more material thrown off the asteroid, you have more of a shove from that ejected material, you have a larger change in the orbital period. And one of the ways we think about kind of how much of an extra shove that ejected material gives us is by comparing that to the amount of momentum that's coming from the spacecraft. And the predictions for that ratio were between 1 and 5. And what we found was that the number we solved for that based on DART data was about, 2, 2.5, something like that, 2.6. There's a fair bit of uncertainty in that based on the unknown density of Dimorphos. If you want the exact number, I'll look it up and give it to you. But it's between 2 and 3, and there's a lot of uncertainty on that. So it was at the higher end, of some people's predictions, but it was within the 1 to 5 that had been predicted in papers prior to impact.
We'll be right back after this short break.
Hi, I'm Asa Stahl, science editor from the Planetary Society. Are we alone in the universe? Humanity has been fascinated by this question for millennia, and today we are closer than ever to finding the answer. Join me in a new online course from the Planetary Society, where we'll explore the search for life beyond Earth. We'll journey through our solar system and beyond, guided by the leading scientists in the field, as we uncover what life needs to form and survive, and how we can use scientific strategies to potentially detect life on other worlds. Whether you're a curious space enthusiast or a passionate advocate for exploration, this course will not only satisfy your curiosity, but empower you to actively contribute to our collective quest to discover life beyond Earth. Remember, this exclusive course is available only to Planetary Society members in our member community. So join us today at planetary.org/membership. That's planetary.org/membership.
What was the change in the ejecta over time? I've even read that it kind of looked like it changed colors over time. Some of the particulate changed as it either blew off or was impacted by the gravity.
So this is an area where there's kind of two sets of data. One set of data comes from the Lichia CubeSat, which flew by Dimorphos 2 to 3 minutes or so after impact and acquired images of the ejecta, as we said earlier, in color. And then there's also observations from ground-based telescopes, which can use a wide array of instruments to understand kind of particle distributions and polarization, things like that. And there did seem to be changes, particularly if you look at the system pre-impact and post-impact, that some have interpreted as being related to maybe changes in particle size distributions or things like that. My colleagues who do the ground-based astronomy are the world's experts on those kinds of data. So at this point, what I can tell you from my background is that, yes, changes we're seeing in that may be related to actually the structure of the asteroid. If there's, when you do that impact, you're exposing deeper material as opposed to what was on the surface. So that probably is telling us something about surface material versus deeper material within these asteroids.
Does the difference between these two types of material tell us anything about the formation of the system?
We don't really know how Dimorphos formed from Didymos, right? The leading paradigm is that you have these non-gravitational forces that make small near-Earth asteroids spin up. So increase spin faster and faster and faster. And at some point, they're spinning so fast, the material on them kind of sheds off. And then that material can accrete to form a second or a moon that's orbiting this larger body. So that's one model for the formation of Dimorphos. There's some challenges with that actually based on DART data, because Dimorphos ended up being not so much like a kidney bean shape, but more like a peanut butter M&M shape. And that shape is hard to explain kind of in these formation models. So if you have this scenario, when Dimorphos is forming as a result of material sloughing off of Didymos, they should be made of the same stuff, because you're just taking part of Didymos and moving it into space and recreating it. And that's actually consistent with what the ground-based telescope saw. As you look at the reflectance spectra before and after impact, you do see that there is this similarity in the absorption features, which is consistent with these two bodies being made of the same material, and therefore of Dimorphos being formed as this sort of spin-up process that leads to mass shedding off of Didymos.
And really cool to see more of those examples. Even the Lucy mission, when it did that test flyby of Dinkinesh, got to see an example of that, where we think one of these moons was formed up by this material that was spun off of the asteroid. So it's really cool to get another view of that up close. But you brought up earlier the shape of Dimorphos before this impact. It was kind of an oblate spheroid, or, kind of squished ball. What does it look like now that we hit it that hard? And it's difficult to say because we're not right up on it to see just yet. But what do the predictions say?
The measurements of the shape of Dimorphos come from a couple of sources. One is from ground-based telescopes that are looking at the light curves, the variations in the light curves of the Didymos system as a function of time. And based on that, there can be models made about the aspect ratios of Dimorphos around Didymos. And based on those measurements from ground-based telescopes, it appears that the asteroid's shape fundamentally changed as a result of the DART impact. It became more elongated compared to what it was before. The other source of the data is the proximity images taken by the DART spacecraft. And so we can use information about the spacecraft's location and the camera properties and the sun geometry and trajectory of the spacecraft, the shadows on the surface, to actually reconstruct the topography and shape of the object. And that give us the result that oblate spheroid you mentioned previously. We don't have that kind of in situ up close data yet for Dimorphos after impact, but the European Space Agency's Hera mission is going to go back to the Didymos system, and we'll then be able to see, we have these ground-based observations that are consistent with a more elongated shape, and the Hera spacecraft, those proximity images, my colleague Carolyn Ernst is going to be working on shape modeling with those images to better understand the details of that reshaped asteroid.
I cannot wait to see those images. I know we have to be patient for Hera to get there. All that debris could definitely mess it up. So we have to wait for its launch, which I believe is in October later this year, right?
They currently is scheduled for that. And in the spirit of things you're waiting for. So my colleague Jessica Sunshine at University of Maryland, she was doing some analysis looking at the albedo across Dimorphos, and was seeing the sort of interesting striations across the surface. She's talked about this at LPSC and AGU, for example. And one of the things that got us thinking about was maybe that kind of pre-existing striations on the surface is almost like a background against which you could maybe see ejected material from Dimorphos kind of painted across the surface and give you a clue as to the extent of that disturbance on the surface. So I'll be really interested to see if that striation pattern is still there when Hera arrives.
Yeah, this data is going to be really interesting. I wish we could have had just a whole bunch of things right up against it right after the impact, because there's so much we can't tell in the aftermath from a distance. But hopefully in the future, we have more objects like Lichia Cube that can come along for the ride on these missions. Assuming someone's going to be doing something like this in the next couple decades, we need to be doing a lot more DART-style missions, I think.
DART was critical because it proved that humanity had what it took to potentially prevent an asteroid impact. But you can only prevent an impact if you know where the asteroids are. And right now, we only know where about 40-ish, give or take, % of asteroids are that are large enough to cause regional devastation. So from my perspective, it's not that we need more DARTs in the next 20 years. What we need is to actually first complete the survey of near-Earth objects. And that's why NASA's NEO Surveyor mission is so critical. It's a dedicated space-based infrared telescope whose sole purpose is to find near-Earth objects. And we'll get us to the point, over the lifetime of that mission and even extended, where we found more than 90% of the objects large enough to cause regional devastation. And we'll have found them with enough warning time that we can take action if needed with a technology like DART. So as much as I would love to see more DARTs, I think if we don't know where the asteroids are, we can't do anything about them. So that's the first priority after DART, is to complete that survey.
And thankfully, we've got space advocates all over the world that have been trying to get funding for the NEO-Surveyor mission. And we finally have it on the books. It is absolutely happening. So we've been celebrating about this. And I think Asteroid Day is a great moment for us to celebrate what it means to be space advocates, because we can actually get these things done. And between NEO-Surveyor, all of the asteroid hunters around the world, and missions like DART, this could be the moment that we actually kind of take a hold of human destiny and are able to prevent something like that.
I think you raised an interesting point, though. It's not so much that I'm, afraid of asteroids, because it's a high consequence, low probability event. But it's things like the Lucy flyby of Dinkinich that make me feel uncomfortable, because that was an object that they thought was one asteroid. And voila, it was two. Now imagine you're trying to deflect an asteroid to prevent it from hitting the Earth, and you realize, oops, daisy, there's actually two of them. Well, now that's a bad day for Earth, right? So even once we found these objects, I think it's critical to get to know them. So that involves developing the ability to quickly characterize them, like a rapid response characterization capability, so that you not only know, hey, here's where this asteroid is, it has this chance of impact or not, but now I know enough about it to be able to plan an effective response. There's another gap that needs to be filled after NEO-Surveyor.
And there's also different kinds of asteroids, as we've seen with missions like DART and OSIRIS-REx and all of the other ones that have been going out to get samples. Some of them are rubble piles, and some of them are solid, chunky kind of asteroids, and even in the case of Psyche, metallic. So understanding the difference between these could really change the effectiveness of these missions. And we've only done one test of this kind, but does it tell us anything about how effective this strategy would be on other sorts of asteroids?
The big question is whether the response of Dimorphos to the DART impact is typical. In other words, is it typical to expect that in general, the impact is going to throw ejecta off the asteroid that's going to add that extra shove beyond just what the spacecraft imparted? And so I think that's a reason to do some additional kinetic impact tests, but I think it's safe to assume that the answer to that question is yes, based on DART, that indeed material thrown off the asteroid as a result of the impact will give us an extra shove beyond what the spacecraft itself imparted.
And good to know whether or not it's one or two objects. And this brings me to another thought I was having, because, when you have these smaller objects and even larger objects, in the case of our Earth and Moon system, where our moon is tidally locked to our planet, you get this tidal locking mechanism that happens where the two objects kind of face each other as they orbit. And this was the case with this system. How did that change now that the timing of the orbit of Dimorphos has also been altered?
So I'll first say that we did not directly measure before impact that Dimorphos is tidally locked, but there is really good evidence to believe that it is, and there is no direct evidence that it is not. But that's not quite the same as saying we know it's tidally locked. And after impact, the evidence indicates that it is no longer tidally locked, and that it might be in a chaotic state. And so that's basically we excited the system dynamically as a result of that DART impact, and it's in the process of kind of settling down. And there were even some measurements that were made by the team that kind of showed a settling down process, even within just the period of months following the DART impact, and even actually within a short period of that time. So it'll be interesting to see how that tumbling state, that chaotic state, evolves between now and the time when Hera gets there. Because again, we're relying on these ground-based observations, which are beautiful and powerful, that only see a point source of light, right? They're not actually resolving Didymos separately from Dimorphos. The Hera mission will do that. And so I think to better understand what exactly the dynamical state is of Dimorphos, we have these clues, these signals from telescopes in the ground that it's excited, that it's in a chaotic state. That's not what it was beforehand. But then those up-close observations from Hera will really allow us to understand what exactly Dimorphos is doing at this time. And ultimately, when Hera gets there, I suppose not at this time, because Hera's not there now, but once Hera gets there.
When is Hera going to arrive at this system?
So the Hera mission is currently slated to launch in October of this year, and then it will arrive at the Didymos system in 2026.
October is going to be a wild month for planetary science. Between this and the Europa Clipper launch, I think we're all going to be just losing our minds watching live streams. But then we have to wait for Hera to get there. What are the biggest mysteries that you're hoping Hera can help us solve in this aftermath?
I mean, I'm biased because of my background and my role on the team, which was to do the shape modeling and impact trajectory reconstruction. One of the big uncertainties is the mass of Dimorphos. We know a lot about the size and shape of Dimorphos, but we don't actually know how much it weighs. We made assumptions about what the density of that object was, and then by making those assumptions, you get a mass because you have a volume from the shape. But the mass of that asteroid is critical because when we think about how much of an extra shove that ejecta provided compared to the impactor, that depends on the mass of Dimorphos. And so with that direct measurement of the mass of Dimorphos by Hera, it will refine substantially our understanding of what that momentum enhancement was from the ejecta off Dimorphos. So for me, that is my personal question of interest. What exactly is the mass of Dimorphos? And then what does that do to that momentum enhancement calculation?
I'm just really excited to see whether or not we left some kind of physical hole in this thing, like a crater or something that we can see with a different sort of material underneath. That could be really exciting, but we won't know until we actually get there to see it. So I just have to be patient.
Well, patience can be hard. I think, so the DART spacecraft kind of landed right amidst, well, I should say landed because it didn't gently sit down. It slammed into the asteroid at 6.1 kilometers per second amidst this sort of nest of 3 boulders. And, whether those boulders, they've probably been completely disrupted. But there's also an example from the Hayabusa 2 small carry-on impactor experiment where some boulders just moved. So they didn't, they just moved. And lots of uncertainty about the strength of the boulders and the strength of the aggregate boulders in Dimorphos. So interesting to see, where do those boulders go? Are they completely disrupted and they don't exist anymore? Did some of them get moved around? Maybe not the ones those 3 right at the impact site, but there are several other very distinctive boulders that you could then track and say, yep, that's moved. Yep, that's moved, or this one's still in place. I think there'll be a very interesting study of the boulders in and around the impact site to see what's changed as a result of the impact, particularly in the context of this overall kind of shape change, this more elongated shape that appears to have resulted from the impact.
Watch, it's some kind of strange potato shape now.
but there's many strangely potato-shaped asteroids, like Eros, for example, or Itokawa. I mean, one of the things about asteroids, and you alluded to this a little bit earlier, is that everyone we've gone to has been different. So it's hard to say, what's a typical asteroid? The shapes of these objects are just wonky. And I'd encourage people to take a look at Planetary Society for a while. I don't know if you still have it, but a montage of all the different asteroids, that have been visited by spacecraft. And you can see, they're funky.
They are. I'll add that image to this episode page of Planetary Radio for people to see because they really are wonky. And the more we learn about them, the more surprised I am. Every single one of these objects definitely throws me for a loop. And just being there with all my coworkers online to watch as this first effort to really test the kinetic impactor method went off. And the moment that it smacked into that object and the image didn't even fully download. It was half red and black. It was such a moment, all of us just screaming together at our computers. So I can't even imagine what it's like for you and the team having such a successful mission.
It's exhilarating. There are times when it wasn't always clear that we would succeed in hitting the asteroid. And, by the way, we're building a spacecraft during COVID.
Yeah.
So, the launch was in 2021 when COVID hit, different components of the spacecraft were in different parts of the country. The team was then having to work to build a spacecraft under social distancing and COVID protocols and testing. And of course, you're in clean rooms. I mean, there was a lot of work that went on to make DART a success. And it wasn't always clear it necessarily would be, And in the end, everyone is very confident everything got worked out. And that's how it goes with missions. There's always something that comes up, that raises people's stress levels. But it was really satisfying to see all of the hard work that came together, from the engineering team who worked so hard to build the spacecraft during COVID, but also designing it beforehand, the mission operations team working on flying that spacecraft and commanding it, navigation teams, the people using the telescopes on the ground. It took hundreds of people to make that moment happen where you saw that final image with about 10% image and then that red area. Hundreds of people around the world, as well as at Johns Hopkins APL, which managed the mission for NASA, to bring that successful humanity-defining moment to fruition.
Well, thank you from me, but also the rest of the team and all of our people around the world that love planetary defense for helping to make this happen because we needed this. It makes me feel less stressed out. I think it makes a lot of other people feel stressed out. And it's the beginning of a whole new age of us being able to defend ourselves. So Thank you to you and the team, and I cannot wait to see what happens when Hera gets there.
You're not the only person holding your breath. There's a lot of people who are waiting tensely to see exactly what that mission reveals.
Well, thank you so much, Terik.
It's been my pleasure. Thank you.
The Planetary Society has funded efforts to find, track, and characterize near-Earth objects practically since we were founded. It's one of our core enterprises, and in 1997, our members and supporters helped us launch the Shoemaker Near-Earth Object Grant Program. It funds amateur and professional asteroid hunters around the world. The program means a lot to us, especially to Dr. Bruce Betts, our chief scientist. He's deeply involved in reviewing and choosing grant winners. Let's check in with him for what's up. Hey, Bruce.
Hey, Sarah.
Coming up on Asteroid Day. No big deal, just thinking about saving the world.
That's kind of a big deal, don't you think?
I mean, it really is, though, when you think about the fact that we're finally doing our first actual kinetic impactor tests. We've got these really cool simulations that are going on where we're talking about planetary defense and trying to figure out whether or not we're actually capable of saving our planet. We're just out the gate on this, but I think we're making good progress that the non-avian dinosaurs would be proud of. If they had the capacity.
Okay, thanks. That part confused me. No, we are doing those things, and I would say probably more importantly, we're discovering more and more and setting up more facilities for discovery, follow-up, and characterization, because we need to know they're out there and what their orbits are before we can do other things. But it's coming along. I've seen a lot of improvement over a couple decades, and there's still a lot to do, but at least we're doing stuff. We're saving the world, or really saving people on the world. The Earth doesn't really care that much.
That and all the puppies and kitties and all of our animal friends. They probably need our protection more than we do.
Yeah, that's a good point.
I mean, I think about that, man. We got to save the world for the cats.
Well, I mean, I wouldn't phrase it. Okay, we can discuss it offline.
I'm also really excited that we have the NEO Surveyor spacecraft that's going to be going up soon. I mean, even Terik Daly pointed it out in our conversation. Testing these kinetic impactors and all the other ways that we can deflect asteroids is important, but without knowing where they are, we can't really deflect them. So having that spacecraft is really useful, but also asteroid hunters all around the world that are doing this great work. And this is a great opportunity for us to talk about the Shoemaker NEO grant program, where we provide funding for people who want to upgrade their telescopes and other things who are looking for near-Earth objects. So would you like to give us a bit of an update? Because it's been a while since we've heard about what our Shoemaker NEO grant winners are up to.
Sure, it's impossible to summarize everything because we've given over 70 awards over the years. I've been running the program for 27 years. And so there's a lot of people doing a lot of things. Many of them are groups of amateur astronomers. Some are individuals. And as you said, basically it's a grant program designed to provide upgrades to people who already have really good setups to go to detect dim objects and take them to the next level. New cameras, robotic control of the observatory, filters, things like that. And we always get more proposals than we can fund, and the ones we fund are doing great. So we've got everything from kind of the usual thing they've done since professional surveys have come on board, which is single locations will do tens of thousands of observations a year to get a motion on the sky to figure out, because once you discover something, you still don't know its orbit very well. And that's something that professional surveys only have limited time to follow up on. So our groups do follow up where they define the orbits better through lots of observations. And then they also do characterization, which is everything from the spin rate of things to discovering whether there's actually a binary where it looked like one and it's actually two asteroids, which is kind of important to understand before you have to deflect something and understand the population. And we've actually got some sites doing discovery again. I mean, they always do a little discovery, but professional surveys have really dominated it. But particularly in the southern hemisphere, we've got various groups, including one in Chile in the Atacama Desert, that are actually have discovered well over 100 asteroids and are doing more and more. So all sorts of things doing well. I wish we had more time to check it out. You can in the next few days after this airs. There will be an article on our website with updates on some of the individual winners and what they've been up to and their impressive feats to help all of us and help humanity. And for those wondering, we will run another proposal cycle this coming year. So not this year, but next year.
Because we do it every 2 years, right?
Yes, right now we're settling into a cycle of doing it, which we've always done roughly every 2 years, because basically that's what we can afford. And then we, on alternate years, now do our STEP grant program, typically the Science and Technology Empowered by the Public, which is higher dollar amounts, fewer awards, and broader program. So anyway, there's all sorts of good stuff. I never cease to be amazed by the Shoemaker Neo Grant winners. Quick note, named after Gene Shoemaker, who passed away in 96, 97, and we started the program in his honor. Was a planetary scientist who did all sorts of great stuff in the field of impact and asteroids.
One of my favorite things that we actually have in the office is this board where there are all these thumbtacks stuck in where we've given grant money to people. Have we hit all the continents yet, or are we still missing any?
You know, I keep sending letters to Antarctica. Yeah, we've done 6 continents, but still not surprisingly missing Antarctica. We've done, I forgot, 22, 23 different countries over the years, and all the continents, but that icy one way down south. So it's a broad, it's an international program. It's an impressive group of folks out there doing good stuff everywhere. In Antarctica, we're looking at you.
I always imagine these asteroid hunters were kind of working on their own, but every time a new group of grant winners comes out, we see their images. I always love the group photos of people at observatories, whole groups of people that are just dedicating their time out of the kindness of their heart, really, to try to save the world and look for these objects. It's really inspiring and really kind of nice knowing that there are people out there that care that much. Well, all right, let's get into it. What is our random space fact this week?
Random space fact. Mars' huge volcano, Olympus Mons, is more than 7 times taller than Mount Olympus in Greece.
Huh.
Same mythology for what it's named for. Now, Mars, it's relative to a reference datum, but it's similar to the surrounding area, and we use sea level. But still, it gives you an idea. It's a whole lot taller, but it's more than 11,000 times taller. Olympus Mons, more than 11,000 times taller than 7-time Mr. Olympia, Arnold Schwarzenegger.
If you could just stack up a whole bunch of Arnolds.
Yeah, it'd take more than 11,000 Arnolds to equal Olympus Mons. So
I heard once that, despite being really, really tall, the slopes on Olympus Mons are so subtle that even if you're standing on it, you might not even realize that you're on such a big mountain. Is that true?
That's actually one of my favorite things about it. But, I try to give you new exciting random space facts, but that's what's really cool. The average slope is roughly, I think, 5 degrees. And it's the size of Arizona, or equivalently roughly France. And so it's a very subtle shield volcano basaltic slope like the Hawaiian volcanoes, but even more subtle. So if you were standing at the top of it and you looked out, over the descending portion, you wouldn't even, without other knowledge, know you were on a giant volcano. You just have a gentle downslope, and your horizon is only some few kilometers off, and this thing's hundreds and hundreds of the kilometers. So, yeah, weird. Except out at the very edges, it's got a steep scarp, but cliffs, basically. But yeah, it's kind of hard to imagine.
Yeah, just ruining everyone's plans to go sandboarding someday on that place. But I recently read an article that suggested that there were some really interesting ideas about why there's that moment where you get that steep scarp, as you described. Some people think maybe it was surrounded by water at some point, but there's a lot more research that needs to be done. That's really cool.
Aliens.
All right, let's take this out.
Not actually, just to be clear. All right, everybody, go out there, look up at the night sky, and think about the way that leaves influence your life. Thank you, and good night.
We've reached the end of this week's episode of Planetary Radio, but we'll be back next week with even more space science and exploration. Love the show? You can get Planetary Radio t-shirts at planetary.org/shop, along with lots of other cool spacey merchandise. Help others discover the passion, beauty, and joy of space science and exploration by leaving a review or a rating on platforms like Apple Podcasts and Spotify. Your feedback not only brightens our day, but helps other curious minds find their place in space through Planetary Radio. You can also send us your space thoughts, questions, and poetry at our email at planetaryradio@planetary.org. Or if you're a Planetary Society member, leave a comment in the Planetary Radio space in our member community app. Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible by our members who think that we owe it to all life on Earth to do what we can to protect this beautiful planet from asteroid impacts. You can join us and help support near-Earth object observers all around the world at planetary.org/join. Mark Hilverda and Ray Paoletta are our associate producers. Andrew Lucas is our audio editor. Josh Doyle composed our theme, which is arranged and performed by Peter Schlosser. And until next week, Ad Astra.